Hello, everybody. My name is Dr. Mike Lohuis. I lead the research team at CEMEX. It's a pleasure to talk to you about sustainability. And because this is such a large topic, I'm going to focus on climate change. And the reason is it's not just important and topical, but also the cattle industry finds itself right in the middle of this debate. So you've all heard about climate change and global warming. So what's going on? You can see the atmosphere forms a nice insulating blanket around the Earth. It has kept the Earth's temperature at an average of 15 degrees C, plus or minus 5 degrees, plus or minus half a degree over the past 10,000 years, basically since the last ice age. And this blanket, without this blanket, the Earth's temperature would probably be around minus 18 degrees C, which would obviously not be sufficient to sustain life on Earth. So what's the problem? Well, the problem is the thickness of this blanket and what the gases are that are accumulating in this blanket. So the greenhouse effect is 50% of it is caused by water vapor, which is moisture in the air that you can't see. And then there's another 25% is made up of clouds, which is water vapor that you can see. Now, the ones that are causing a problem are CO2, which makes up about 20% of this blanket. And the last 5% is made up of CH4, which is otherwise known as methane, and nitrous oxide, N2O, and a few other fluorocarbons. Those all together form this blanket. But what we're currently doing is adding too much CO2, methane, and nitrous oxide into this blanket. And it's causing more heat to be trapped, and it's keeping it from being released back into space. So this is gradually warming our planet and causing a lot of the effects that we're already seeing. So to prevent climate change, we need to rapidly reduce greenhouse gas emissions. Right now, the world emits around 50 billion tons of greenhouse gases additional to the atmosphere every year. 50 billion tons, otherwise known as gigatons, are accumulating, which is causing this gradual rise in temperature. So who is to blame for climate change? Well, it's us, humans. We are responsible for that 50 gigatons of extra greenhouse gases each year. Well, 70% of the world's greenhouse gases are attributable to the top 100 fossil fuel companies. The richest 10% of people consume 20 times more energy than the poorest 10% of people on the planet. The USA has emitted about a quarter of all the emissions that have accumulated since the beginning of the industrial era. And today, China is the largest emitter of greenhouse gases. But the USA still emits 2 times the amount per capita than China does. But what about Canada? Well, Canada is the 3rd largest emitter per capita. Right behind the US and Germany, we use more greenhouse gases or more energy per capita than most of the rest of the planet. And in some ways it makes sense. We drive bigger vehicles, we drive longer distances, we have a colder climate. So there's a lot of energy that we require, but we're also a rich country and we do a lot of things that poor countries can't do. But what about agriculture? Well, it turns out agriculture as a whole is responsible for almost 1/5 of all global greenhouse gas emissions. Well, let's break that down into different sectors. And you can see the energy sector is almost 3/4 of the total greenhouse gas budget for the planet in terms of additional emissions. Ag and forestry accounts for close to 20%, and of that, livestock and manure is about 6%, so about 1/3 of ag and forestry. Next in line would be ag soils, so fertilizer that is put on fields, for example. Just gases that are emitted by soils account for another 4%. And then there's the remainder would be landfills and industry, such as making of chemicals and making of concrete, which is a huge energy user. What about emissions in Canada? Well, it's somewhat the same. We use a lot of energy, both for producing energy, hydro, for example, or for transport. Agriculture in Canada is only about 8% compared to 18% globally. So why is agriculture more efficient in Canada? Well, one reason is that we have fewer people, so we don't, in not having to feed as many people, we don't have to grow as much food. And our agriculture is more efficient than other types of agriculture around the world. We're more intensive, and we use our resources more wisely. But we've still got a long ways to go. Well, how much has changed in the last 15 years? This graph from the Government of Canada shows that in total, we've reduced net greenhouse gas emissions by about 1%. Now, 8.5 megatons or million tons, when you look at that in a global scale, it's not going to be sufficient. If every country did as little as Canada, we're not going to get there. We have reduced the emissions from energy generation, such as creating hydro, but we've used more for transport. So we're driving more, we're driving bigger vehicles. When it comes to the other sectors, agriculture included, we have done some reduction. Agriculture has almost dropped about 1 million tons of greenhouse gas, but it's only about 1%. So we've got a long ways to go. So why all the fuss about methane? I'm sure you've heard about methane in the news. Methane is produced, it's kind of a trade-off. It's a negotiation in the cow's rumen, whereby we invite bacteria into the cow's rumen to help break down cellulose, and that releases sugars and energy for the cow to use in its diet. In exchange, the bacteria release methane, which 95% of it is released through the mouth. So when you hear about cow burps versus cow farts, it's a lot of the reporters like to talk about cow farts, and it's actually not true. 95% of it comes out the mouth, so it's burps, not farts. So sorry, I had to get that off my chest. So that's been one of the reasons that cattle have come into focus in the climate change debate. And now the cattle industry has a bit of a target on its back about methane. Now, how did that get started? Well, it got started back in 2006 with a paper put out by the it's FAO in Rome, called Livestock's Long Shadow. And in this paper, they stated that the livestock sector is a major player responsible for 18% of greenhouse gas emissions measured in CO2 equivalents. This is a higher share than transport. And that headline got a lot of attention. The problem was it wasn't true. Livestock account for about 6%, not 18% of greenhouse gas emissions. The transport sector emits 3 times what livestock do around the world. And there's a few things that they got wrong. It was basically they were comparing apples to oranges. They looked at all the emissions attributable to livestock going all the way back to clearing land to create pasture for livestock. Whereas in the transport sector, they were only measuring what was coming out of the tailpipe and nothing upstream of that in terms of finding resources in the ground, extracting and refining oil, and then transporting it and creating gas stations. None of that was considered. And so it was a kind of a red herring paper, but it's difficult once a paper like that gets so much notoriety and is talked about so much, it's really hard to change people's minds about it. And so we have an uphill battle when it comes to talking about cattle. What we have to help people understand is that cattle produce methane, but it's part of the natural biogenic carbon cycle, whereby cattle eat grass, they produce methane from their rumens, that's broken down into CO2, which is then reabsorbed by plants, and then it goes back into cattle feed once again. So this carbon cycle is a natural cycle that does occur and has been occurring for thousands and thousands and thousands of years on this planet. Now, how is methane different from CO2? Well, one is the global warming potential of methane is higher. In other words, methane has about 28 to 36 times the global warming potential of CO2 over 100 years. And the lifetime of methane is only about 10 years, whereas CO2 lasts thousands of years. CO2 is a very stable molecule and will be here every time we add CO2 to the atmosphere. It basically stays there, whereas methane dissipates after about 10 years. And recently, some good science from University of Oxford has come out saying that global warming potential 100 is not a good predictor of warming emissions as emissions change. A better predictor is GWP star, which better takes into account changes of short-lived greenhouse gases. And the way to look at this is that carbon dioxide, because it lasts a long time in the atmosphere, it's considered a stock gas. So each day or each year you add more CO2, it just continues to accumulate. It's like having taking a shower in the bathtub and having the stopper in the drain. It just will continue to rise until eventually it overflows. Whereas methane, it's like having a shower with the stopper only partly in the drain, and the water is draining out with a little delay, but draining out about the same rate that it's coming in. And as long as we don't increase the rate, we will not have additional warming in the longer term. So that is important to distinguish between a stock gas and a flow gas, which is short term. So how does this impact warming? Well, if emissions are rising, like CO2 and methane are today, those are both going to contribute to warming. And CO2 will accumulate more because it lasts longer, but methane will also continue to increase in its contribution to warming. Now, if emissions are constant, then you'll see that the warming of methane will also remain constant, whereas CO2 will continue to increase. But what about if we were to decrease both emissions? Well, in this case, you can see that because methane is a short-lived greenhouse gas, eventually the warming would go to zero if you were to eliminate future emissions of methane. Whereas CO2, even though you would stop producing CO2, because the warming there's an accumulation of CO2, it eventually would stabilize, but all of that past CO2 would still be part of that blanket and would contribute to global warming. So one thing we could consider is that methane is a way to buy us some time. If we can reduce methane, we could buy some time while we figure out how to decarbonize our energy sector in our economy. So we can play a role by reducing methane. The global methane budget, I'm not going to go through the details here, but the net emissions of methane is about 10 million tons of methane per year. And if you were to look at the warming potential of that, it would be the equivalent of about 0.3 gigatons. So from a 50 gigaton surplus, we could reduce by about 0.3, which is not much, but it would be something to help contribute to solving climate change. So how can we reduce ag emissions? Well, let's start with the big ones, right? So you can see we've peaked in ag emissions at the end of the last century. So the biggest contributor was land use change and forestry. And that means that agriculture's footprint was expanding into rainforests, into other forests, into wetlands. And by expanding the footprint and cutting down trees and draining swamps, you release a lot of carbon. And that was a big contributor to how agriculture became one of the major contributors to this warming planet. On top of that, you have this orange area, which is enteric fermentation, in other words, methane from ruminants. On top of that would be rice cultivation, manure management, synthetic fertilizers, manure on pasture. So these are some of the things that we can work on. So what's the thing that we can do best? Well, continue to increase yields. What that does, by producing more kilograms per hectare, then we need fewer hectares to produce the same amount of kilograms. Or stated another way, if we can double the amount of yield from existing hectares, then we would only need half as much land to produce the same amount of food. And so some of that extra land could be turned back into forests or back into wetlands, and we could turn some poor farmland and use that to sequester carbon. And that would be a huge sponge for this extra CO2 that is accumulating in our atmosphere. So agriculture, by being more efficient, we can be part of the solution for climate change. And the same applies to ruminants. If we can increase the yield per animal, so more kilograms of milk per animal, or if we can improve the feed efficiency, feed conversion in beef cattle, then we can get more kilograms of meat per kilogram of feed, again, producing more feed with less land. We could reduce flood irrigation, which produces methane, manage manure better, so we incorporate it more into the soil. We use it more wisely, use less fertilizer, remove inefficient acres, don't put more fertilizer on parts of the field that don't need it. So being more precise in how we apply our inputs can go a huge way to helping ag become more efficient. So how sustainable is Canadian dairy? Well, Canadian dairy cows produce 3 times more milk than 50 years ago. And these are due to improvements in genetics, cow comfort, herd management, feed efficiency. Dairy production represents less than 1.3% of Canada's total greenhouse gases. Because it's very efficient industry, and Canada as a whole is a more energy intense economy, dairy is not a big part of the problem. We produce about 0.94 kilograms of CO2 per liter of milk, and that's about 1/3 of the global average. So we're doing pretty well from a dairy industry standpoint, but we can get better. The carbon footprint, water consumption, land use have all decreased in the past 5 years, and I think reducing our dairy industry's environmental impact is an ongoing effort and a priority for dairy farms. Now, Dairy Farmers of Canada have also put out an online tool which can help you measure the footprint, the environmental footprint of your dairy. And what it looks like is, and I will provide a link for this, but you'll get a screen that looks like this. You can learn about different practices that you could use to make your farm more efficient, and you can measure and benchmark your farm against others and take action. And this is something I would encourage you to do if you have a dairy farm. Go in, have a look, see how you can improve. There's 4 key areas. One is feed production and practices, so how you grow food, grow feed, no-till, low-till farming, more renewable fertilizers, more precision ag, better manure handling and nutrient management. Cow care and cow efficiency are a big part of this solution. And then on-farm energy efficiency and creation of renewable energy. These are all ways that dairy farms can contribute to becoming carbon neutral or closer to carbon neutral. Some of the desired outcomes that have been stated by 2050 is the dairy industry would like to reach net zero emissions. We'd like to have a significant improvement in water use and quality of water. Dairy farms can provide nutrient-dense foods that can allow the food industry to be more sustainable. And farmers can realize value from continuous improvement on their own farms. And hopefully at some point there will be carbon credits for farmers to be rewarded for those kind of sustainability actions. What can the beef industry do? Well, the beef industry has been very active in Canada. There's a Canadian roundtable for sustainable beef, and they have put together a sustainability assessment and strategy. Some of the things that they've desired is to maintain 1.5 billion tons of carbon stored on beef lands. That's a very important sink for carbon. And by managing those pasture lands well, we can sequester an additional 3.4 million tons of carbon each year. By 2030, the beef industry wants to reduce greenhouse gas emissions intensity by 33%, so 33% less greenhouse gas per kilogram of meat produced. And then, of course, we'd like to reduce food waste. Right now, a third of our food is wasted, and so we need to produce and use all of this energy to produce food that a third of it never gets eaten. So what can I do? What can you do to be part of this? Well, first, don't give in to despair. You might think this problem is way too big, so break it down into smaller problems. It's the same thing that applies with homework or big assignments, is break it down into smaller things that you can tackle one at a time. Stay positive. Science already knows how to get to a net zero economy. It really just takes the political will to get there. Learn what you can do in your household or your farm to become more sustainable. And the next slide, I'll have some information on where you can find this. Be a good example for your peers. If, believe it or not, your peers will look to you to see what you're doing. Engage with your friends and family, but do it respectfully. A lot of times people have opinions and they are entitled to their opinions. The best thing you can do is don't criticize their opinions. Ask them why they think the way they do, and then listen. And the more you listen to them, the more likely they're going to want to listen to you. And if that time comes, make sure you're aware of what can be done. Educate yourself about what you can do and what our industry can do to become more sustainable. And some of these sources I would recommend, and these links will be provided to you, but looking at greenhouse gas sources and sinks, the US EPA has a very good site about understanding greenhouse gas emissions. There's some good information from the CLEAR Center at the University of Davis that talks about our cows causing climate change. There's also a very good paper that just came out talking about what agriculture and agriculture technology can do to get to a net zero economy. Dairy Farmers of Canada have a good site. Canadian Roundtable for Sustainable Beef has a good website. Guardians of the Grassland has a good website, plus a nice film that describes how grasslands can contribute to sustainability. And Canada in general is part of the Sustainable Development Goals, and there's a data hub associated with that. So I thank you for your time. I look forward to engaging questions that you may have, and I know that there's a number of questions that you'll be asked to